Hello, my name is Nick Shipman, and this is Interactive Advanced Concept Presentation 5, Penny Oxidation. I keep wanting to add a Z, but it's not. So I've got my table salt right here. I don't know how well you can see it. Let me see if I can get a little bit better, but teaspoon of table salt in there. I'm going to pour a 1/4 cup of vinegar. Pour it in, and I'm going to give that a quick stir and let that dissolve for a moment here. While I am letting this dissolve, I probably should have. That's dissolving, all right. So while I'm letting this dissolve, and then I've got a few tarnished pennies here. So while I'm talking about this, letting that dissolve, I just want to talk really quick about why the pennies are oxidizing, or why they have oxidized. I feel like, so the pennies have oxidized. So pennies, what they're made of, it's actually zinc coated with copper. And so when the copper is exposed to oxygen, which there's oxygen everywhere, it creates a copper oxide. So here's my balance equation for that. 2Cu plus O2 leads to 2CuO. So what is happening is actually it's a redox reaction, an oxidation reduction reaction. So the copper itself is being oxidized. It's losing 2 electrons and going from Cu to Cu2+. And then the oxygen is being reduced and it is gaining 2 electrons from the copper. So it's becoming O2-. And so we can clean that, but we'll use vinegar and salt. And so what is happening when you mix vinegar and salt? Well, I'll tell you. You have acetic acid and sodium chloride, your vinegar and your salt. So your CH3COOH plus NaCl leads to CH3COONA, sodium acetate plus HCl, which is hydrochloric acid, which is a strong acid. And so we will then add, of course, the copper oxide, the pennies, and that's going to react with the copper, that is going to react with the hydrochloric acid and the sodium acetate. So we'll show that right now. And I hope this has dissolved enough to let this happen. So we'll do this for a few seconds. I think up to like 15. Maybe like, oh my gosh, I'm watching it happen. This is really neat. I knew it was gonna work, but it's actually cool, and the chemistry involved is quite neat. And there we go. I can see it. You can see, yeah, you can see it pretty good there. So I'll throw it in there, and I got a couple others I'll throw in. My wife will be so happy. She'll come home. She's working a night shift tonight. She'll come home and have some clean pennies. How lucky is she? So the copper oxide on the outside of the penny is reacting with the hydrochloric acid and the sodium acetate. So you have your like parallel, it's happening at the same time. So your copper oxide with the sodium acetate, that's going to react to form 2H2O plus a copper acetate, which is going to, and then you have your copper oxide with the hydrochloric acid, 2HCl. It's going to also lead to H2O and copper chloride. Okay, and so that happening, the copper acetate that forms is soluble in vinegar, so that's what's giving it the shiny appearance. So it's taking that copper oxide off. Taking that oxide off, the oxidation off the copper, and creating a shiny appearance. And I believe if you left it in here long enough, it'd actually take off all the copper and get down to the zinc. And so, yeah, that is the penny oxidation, the chemistry behind it.